Welcome to Khetz tutorials, and in this video I'll be covering a few things about triangles and similarity specifically. So before we proceed, I just want to talk about a few things in terms of triangles that you should know, or which I expect you to know by now. And so let's just get right into it. So if you have I'm just going to do rough sketches, and I hopefully will have much more neater diagrams later on. I just want to talk about this in passing. Right. So let's draw 4 triangles, and we're going to talk about each diagram. So don't mind the diagrams now, they're going to get a little bit better. Just that I want to move through all of this quickly. So the first thing which I expect you to know is if this triangle is said to be ABC, the sum of A, B, and C adds up to 180 degrees. So the angles of a triangle are supplementary. That is what that means. Another thing which I expect you to know is that the exterior angle of a triangle is equals to the sum of the interior opposite angles. So C1 over here is equal to the sum of A and B. Another thing which I expect you to know is if you have an equilateral triangle, so all the sides are equal. That is why we have these lines over here. So all the sides are equal, and so if you have an equilateral triangle, all your angles are going to be the same value. All your angles are going to be the same value, and that value is 60 degrees. And this is due to the first point which I talked about over here, because all the angles have to add up to 180. And this is also linked to this one over here, because for this case, all of the sides are equal. And this next point says that if you have equal sides in a triangle, they both are facing equal angles. So angle B is equal to angle C because AB and AC are equal, right? So this is the same thing that applies here as well. All of the angles are facing equal sides, and therefore would have the same value, the same quantity as the angle. So this one finally says angles opposite equal sides are equal, right? Or sides opposite equal angles are equal. So these are just the basic things which I expect you to know by now from previous grades. And yeah, so let me just erase all of this, and I'm going to proceed to talk about today's topic, which is specifically similarity, right? And let's write that. So we're going to talk about similarity. And we say that polygons or shapes are similar. So polygons with the same, right? Polygons with the same number of sides. So from the get-go, you can see that we can't say a triangle is similar to, let's say, a square, because they don't have the same number of sides. So only do this comparison when we have polygons with the same number of sides. We say that they are similar if their corresponding angles are equal. Their corresponding angles are equal, or all basically these two have to hold, so both of them actually, it's not an or, it's an and. So they're similar if their corresponding angles are equal and all of the corresponding sides are in proportion. All right, so these are the conditions for us to basically say that two polygons are similar. So even before I proceed, I just want to highlight the difference between similarity. So similarity versus congruency. Right. So similarity, we say that things are similar when they look alike but are not exactly the same. But with congruency, they are exactly the same. Which means if I have a square here and I fit another square exactly onto the other one, they are congruent. But if I have a bigger square and a smaller one over here, and they happen to have they obviously have the same angles, and the sides, each of the sides are proportional to each other, then we say that these two are similar. But in this case, if this fits exactly into that, it has the same angle, the same angles everywhere, and the exact length for each side, then we see that these are basically congruent. Now, the reasons for congruency, some of the reasons or all of the reasons are basically side, 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 angle, side, and angle, angle, side, or side, angle, 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 side, angle, or right angle, hypotenuse, side, right? So that was just a highlight of the difference between similarity and congruency. So the symbol for similarity, they have three lines which look like that. And the symbol for congruency, so this is the symbol for congruency actually. For similarity, you have these three lines which look like that. That is for similarity. And now for congruency, we have lines which look like this, which means it's exactly the same. So it's basically three lines, but their orientation determine whether it's similarity or congruency. So this is the one which we use for similarity, which is basically what we want to talk about, which is the main thing that we want to talk about in this video. And so we are going to start with a theorem, right? We're going to start with a theorem, and that theorem says, so let's call it theorem 2 because we've already covered theorem 1 in the previous video. If you haven't looked at that, please look at it. So theorem 2, it says that if, let me create some space, right? If two triangles are equiangular, which means they have the same angles, then their corresponding sides are in proportion, and the triangles are similar. So let's read this and understand what it's actually saying. It says, if two triangles are equiangular, then their corresponding sides are in proportion and the triangles are similar. All right. So let's actually look at proof for this. You can actually be asked in a test situation to prove this, and we're required to prove that if we have, so let me now draw a neat triangle, unlike the ones which I had before. We're required to prove that if we have a triangle like this and we construct something which looks like this, we are required to prove if that is A, that is B, that is C, and we have an S and call that T. Required to prove that AB, so let's shift that so we see where AB is. AB divided by PQ, which is going to come from another triangle which I'm going to draw, which is equals to AC divided by PR, which is equals to BC divided by QR. So we're going to make, let's say we initially given a triangle ABC. We just drew that ST line to help us do our proof. And we're also given triangle, another triangle. Let's say we're given another triangle over here, which is, so let's draw it closer to this side so we have everything in our view. So let's say we're given another triangle which is much smaller or bigger, it doesn't really matter. We just want to prove that the sides are proportional. Let's say I had another triangle which looks something like that. Just imagine that these triangles are actually closed. The proper way of drawing triangles, they're closed. So that is PQ and that is R. So we want to prove that these two, ABC and PQR, are similar, right? We want to prove this, that ABC and PQR are similar. And to prove that, we're going to come back to this that says if two triangles are equiangular, then their corresponding sides are in proportion and the triangles are similar. So we want to prove that the sides of all of these triangles or of these two triangles are actually proportional. And to do that, we're going to prove this here, which is our required to prove statement. So let's do that. We basically construct our AS to be equals to, so that is what this line is for. We construct our AS to be equals to our PQ. So AS equals to PQ by construction. And we also construct our AT to be equals to PR. The reason for that would be by construction. So we want to prove, so we make some constructions to actually help us prove this. And let's just say we were given the following. So given that A, the angle A is equals to P, the angle P, given that the angle B is equals to the angle Q, angle C is equals to the angle R. This is going to be helpful because we now know that these two triangles are equiangular. So you know that for sure because we are given that their angles are equal over here. So given that, and now we want to prove the second part, which says if two triangles are equiangular, then their corresponding sides are in proportion. So we want to prove this part, which says the corresponding sides are in proportion, after knowing that the angles are actually equal. So let's proceed to do that using this construction. And the way that we'd actually proceed would be that, so if you look at AST, so let's look at AST, let's come here. We're going to provide reasons why this is the case. So let's look at AST. So triangle AST is congruent to triangle PQR. And this is why. The reason for that is side, angle side. And that is what we were talking about previously here. So I'm just going to state the reasons once again so that we have some sort of flow. Side, angle side. So we constructed AS to be equals to PQ. So this is by construction. So that is side, that is the side part. And we are given that A is equals to P. It's given to us here in the statement, which we have over there. We're given A is equals to P, and we constructed AT to be equals to PR, right? That was by construction. So that covers side, angle, side. And therefore, these two are congruent. That is the statement which we made up here. But that is not what we're required to prove. But that is going to be quite helpful to prove what we want to prove. So then, we're going to come down here and say that since this value of, or this triangle over here, AST is congruent to that one, it means that this angle over here, let's call it 1, so S1 is equals to Q, right? So S1 is equals to Q, but, so let's write our statements so it makes sense. S1 is equals to Q because we proved that AST and PQR are congruent, but we know that B is equals to Q, which is from that. So this is given to us, right? And this means that S1 is also equals to B, right? Now that we know that S1 and B are equal, we can conclude that ST is parallel to BC because we have corresponding angles. So you now say that therefore ST is parallel to BC. The only way that we'd have this angle S1 equals to B would be if these two lines ST and BC are parallel. And we can conclude that these are parallel because we have corresponding angles that are equal, right? And now that we have corresponding angles that are equal, we're going to use the theorem which we talked about previously, which is theorem 1. And it says a line which is parallel to one side of a triangle divides the other two sides proportionally. And therefore, we can conclude that, so since this line is parallel to that, we can conclude that AB divided by AS is equals to AC divided by AT. And the reason for that conclusion is line parallel to one side of triangle. So this is theorem 1, which says a line parallel to one side of a triangle divides the other two sides proportionally. And from that proportion, we can also conclude that AB divided by PQ is equals to AC divided by PR. And this is because we constructed our AS and AT to be equals to PQ and PR respectively. And we've effectively proved that the sides, the corresponding sides, are indeed in proportion. And these two actually lead us to the final proportion of BC and ST, which is the same as QR. So ST is the same as QR because AST and PQR are congruent. So that'll be equals to BC divided by QR. So we have effectively proven this case, and I'm sure that there might be some confusion because I was touching up on different things at different times. But if you really followed this, I really do hope that you got how to prove this. If it was quite unclear, I'm just going to go through it once more. So given that the angles of this triangle and this ABC triangle are equal, you're required to prove that, because the theorem says if two triangles are equiangular, then the corresponding sides are in proportion and the triangles are similar, right? And for similarity, they have to have the same angles and the sides have to be in proportion. So we want to prove the proportionality part of it. And to do that, we first constructed AST such that AS is equals to PQ and AT is equals to PR. And we're given that the angles are equal. So our A is equals to this P, which is in question. And therefore, we can conclude that this AST is congruent to that. Now that the two are congruent, we can actually work with this one and actually try to see how it's related to ABC. And during our analysis, we saw that we can actually say that S1 is equals to Q, but in the question, we're given that B is equals to Q, which means that S1 is also equals to B. So if S1 is equals to this, so if this S1 is equals to this Q because of congruency, which we proved, and we're given in the question that B is equals to Q, then we can also say that this S1 is equals to B as well, right? So now that we have S1 equals to B, the only way that that can happen is if this line is parallel to this line. So if that holds, we can come back to the first theorem, which says a line which is parallel to one side of a triangle divides the other two sides proportionally, which therefore makes us to make this conclusion that the sides are in proportion. Now that the sides are in proportion with respect to AS, we can relate that to our triangle in question, because AS and PQ are equal and AT and PR are equal because AST and PQR are congruent. So basically these two statements are the same. And this specifically is the statement which we had in our required to prove statement, and that is why we had to switch to it. And that is how you basically prove that if two triangles are equiangular, then their corresponding sides are in proportional and the angles are similar. So if anything is unclear, once again, just go through the video once more, and if it's still unclear, just leave a comment in the description and I should explain what you don't understand. If you like this video, please go ahead and give it a thumbs up, and if you haven't subscribed, please subscribe. I will see you guys in the next video.